Hello, mathematicians. This is Mr. Mailhot. Let's do some math. You should be in page 8 of your packet. Remember, you can pause the video at any time, rewind a couple minutes if you need to. You should write down everything that I write down. These are kind of like our notes, and you need to complete these packets as well. We're going to look at one other small little topic in our big topic of linear equations and lines. And you guys, I'm not lying when I say this was my favorite topic back when I was in middle school and learning this, because it was something small and it seemed really complicated, but it was actually, to me at the time, seemed super interesting just because they were, again, kind of some special cases. We're talking about parallel and perpendicular lines. Y'all know what parallel lines is. I bet you most of you do. The definition for there's some different definitions we could give, but the one I like to use for parallel lines are lines that never intersect. What do I mean by intersect? That's where they cross. Intersections are where things cross, like roads have intersections, right? You pause at the stoplight. That's an intersection because the roads cross. Parallel lines never cross. So algebraically, or with equations, how do we know if they're parallel? Well, they have the same slope. If they have the same slope, they'd be parallel. And think about that. They give you this example here, lines with zero slope. Are those ever going to cross? Nah. We could have a one with a positive slope like this. Now, I'm not a perfect artist, but if those were parallel, they're never going to cross. They could be a negative slope, like this, and they never cross. They might even be perfectly vertical. These would both be like lines that would just be like x equals 5 and x equals 2. They would never cross. The symbol that we use for parallel lines, is just two parallel lines, straight up and down, okay? Perpendicular lines, perpendicular. The definition of a perpendicular line, if you don't know, are lines that intersect at exactly 90 degrees. Exactly right angles. Remember, 90 degrees is a right angle. Lines that intersect at exactly 90 degrees. Now, we're not going to get out our compasses and measure it. We can look at it algebraically, how we know if they intersect at 90 degrees. And here's how. If their slopes are opposite, let me write that better. Opposite reciprocals. Opposite meaning opposite signs, positive or negative, and reciprocal means flipped. The symbol that we use for perpendicular lines is kind of an upside down T. And sometimes people like to put the little right angle there. It's not necessary. If you just want to do this or this with the... let me make a right angle in there. Or that. Either one's fine. Okay? Let's do some examples. So what are negative reciprocals? Well, here's an example. If the slope is 3/4, that's positive, so make it negative. And the reciprocal would be 4/3. For number 2, well, 2 is positive, but remember you can always make a whole number into a fraction by putting it over 1. And so the opposite or negative, some people like to say negative. I prefer the word opposite because if it's already negative, then it becomes positive. You should do the opposite. Back to number 2, the opposite reciprocal of that would be a half. Oh, not a half. Negative a half, right? You got to have that opposite sign. For number 3, the opposite reciprocal would be positive 8/7, right? It was negative and now it's positive fraction flipped over. For 1, well, remember that's like 1 over 1. So the opposite reciprocal of that would be negative 1 over 1, which is just 1. And for 0, that's an interesting one, because 0, you can still make that into a fraction. And if you take the reciprocal of that fraction, you get 1 over 0, and we still would have to make it opposite, negative. But if you divide by 0, that's undefined. That'd be a slope that would be completely vertical. Remember slope, dude? All right. Let's do some examples here. Given some ordered pairs, determine if the segments A, B, and C, D are parallel, perpendicular, or neither. All right. To do that, we got to use our slope formula. I'll write it up here. You can write it too if you need to remember. Remember y2 minus y1 over x2 and minus x1. Make yours look nicer than that. All right. Let's do the first one. AB. Remember, you write the big old fraction bar, put the minus signs, use parentheses. Now we can plug in the points from AB. So y2 would be this second y, 6, minus y1 is 3. And on the bottom, x2 is 2, and x1 is negative 2. So I'm seeing 3 over 2 minus negative 2, that's plus 3 over 4. For CD, we do the same thing, and you guys will get, some of you are really good at finding slope already. If not, this will help you out. It'll be so fast once you get good at it. Same thing. Here's y2 and y1, so 3 minus 0. And x2 and x1 is going to be 3 minus negative 1, which again gives us 3 over 4. So these have the same slope, yeah? 3/4 and 3/4. So for number 1, they are parallel. Let's see, what else did I want to do with you guys? You guys can do the rest of these. You're going to find the slope of each and see if they're parallel, if they have the same slope, perpendicular, if they have opposite reciprocals. If they're just two random numbers that aren't opposite reciprocals or are not the same, then that's neither. Okay? Let's move on to the next page, and you can come back and finish these problems. Or if you'd like to pause now and do them before you come back, you can do that too. I'm going to move on. Let's say we're given some equations. And the same thing, we're going to determine if they're parallel, perpendicular, or I guess neither. I'll use an N for neither. Well, number 9, these are already in y equals mx plus b, so I see an m there, an m there. Remember, m represents the slope. These are the same, aren't they? So, parallel. For number 10, same thing. They're in y equals mx plus b, and there's the slopes. This one is 4/5, and this one is negative 5/4. Are they opposites? Yeah. This one was negative, this is positive. Are they reciprocals? Yeah, if you flip this one over, it'd be the same as this one flipped over. They're opposite reciprocals. That means they are perpendicular. Let's do one more, number 12. Just because number 12, you have one extra step, you got to convert to slope-intercept form first. So that means subtract x on both sides. 6y equals negative x plus 30. You guys are good at this by now. This one, you just got to divide by 3. I'm doing one step at a time for each one. Let's make a little space. That would give us y equals 6x minus 2. And this one, if you divide by 6 on both sides, I'm getting y equals negative 1/6 x plus 5. Well, 6 and negative 1/6, those are opposite reciprocals, which means they're perpendicular. All right, your job is to finish the rest of these. Remember, you learn and get smarter by doing, not just watching. So now go do the math. Bye.